Today's notes are very short, and we only have one learning objective for today, which is that by the end of class, you should be able to list and describe the 5 basic types of reactions. So list, give their names, describe, give me a general idea of what that reaction looks like. There are thousands of different types of chemical reactions, and it would be impossible and unrealistic for me to expect you to memorize all of them. In fact, I don't have them all memorized. Okay? Scientists have found ways around having to memorize individual equations. What they do is they group chemical reactions into different categories based on patterns in the way that the chemicals react. And today, we're going to go over the 5 most common categories. We call them the 5 basic types of chemical reactions. First one is called a synthesis reaction. In a synthesis reaction, 2 substances combine to form one compound, sometimes 3 or 4 substances, but the idea with the synthesis reaction is you take simple parts and you combine them into a compound. The general reaction for this would be A plus B reacts to yield AB. So A and B are individual elements, and they would combine to form a compound. In the lab that we did, when you put the copper foil into the fire, you were causing a synthesis reaction to happen, because what happened is you took copper and combined it with oxygen, and as a result, you got copper oxide. See how you have 2 simple substances combining to make a compound? That's a synthesis reaction. You can recognize synthesis reactions because you start with more reactants than you end up with products. You have 2 or 3 or sometimes 4 reactants and 1 compound as your product. Another example of this would be when you combine magnesium and oxygen and you get magnesium oxide as a result. 2 simple substances combining to form 1 complex product. The second type of reaction is called a decomposition reaction. Decomposition reactions are essentially the opposite of a synthesis reaction. In a decomposition reaction, you have 1 complex compound and it breaks down into 2 or more simple substances. So, like I said, essentially the opposite of a synthesis reaction. The general reaction looks like compound AB breaking down into elements A and B. So when we did the lab in class, we heated up baking soda, which is sodium bicarbonate, and caused it to break down. So that would be our decomposition reaction. You're taking 2 sodium bicarbonate and breaking it down, and we got carbon dioxide, water, and a substance called sodium carbonate, which is just Na2CO3. You can recognize a decomposition reaction because you're going to start with just 1 reactant and break it down into multiple products. Another example of this is breaking down hydrogen peroxide into water and oxygen. 1 substance breaks down into simpler products. So notice that the products produced by this aren't always individual elements. In this case, we have water, which is still a compound, but it is a simpler compound than the one that we began with. So you're always breaking down into simpler substances. The next type we're going to talk about is what's called a single replacement reaction. Okay. In this, a single element is going to replace another element that's already in a compound. The general reaction is compound AB and then element C, where element C comes in and takes element B's place, and you're left with compound AC and element B out on its lonesome. In the lab we did, the reaction between aluminum and copper sulfate was a single replacement reaction. So you had aluminum metal that was by itself, and when we added it to the copper sulfate, what happened was the aluminum took the place of the copper, which is why the color changed in the liquid, because when you have dissolved copper, it is blue, but when it's not dissolved in the water anymore, then instead of being blue, it appears as the copper metal we are used to. So it deposited copper metal onto the foil, and then aluminum left the foil and went into solution, and we were left with aluminum sulfate. You can recognize single replacement reactions because the number of reactants and products are going to be similar, but the atoms will have rearranged themselves. Another example of this would be silver nitrate with copper added to it. The copper would take the place of the silver, and then you'd have copper nitrate, and you would leave silver as a solid metal off to the side. The fourth type of reaction is a double replacement reaction. This is very similar to a single replacement reaction, but instead of just having one element that's by itself replace something in a compound, what happens is you have two compounds, and ions from those compounds switch places. So the general reaction would be if you had compounds AB and compounds CD, then elements B and D that are in those compounds are going to switch places. And so as a result, you'll wind up with compound AD and compound CB. So you can recognize a double replacement reaction because you will see a similar number of reactants and products, but the compounds at the end will be brand new. You will have two new compounds at the end of the reaction. For example, you would have lead nitrate, and you add potassium iodide to it, and as a result you get potassium nitrate and lead iodide. All right, last type of reaction, combustion reactions. Okay. We didn't officially do a combustion reaction during the lab, but you've seen combustion reactions before because combustion reactions are when flammable materials combine with oxygen and they release energy. So we don't have a general reaction for combustion reactions because the types of chemicals that burn are very widely varied. They range from individual atoms to large complicated molecules, hydrocarbons. There's lots of different things that will combust. So instead of having a general reaction, we have some things you can look for to decide if something is a combustion reaction or not. So you can recognize a combustion reaction if it satisfies the following three things. One, you must have oxygen as a reactant. As we discovered during the lab, when you lit the stick on fire and put it in the presence of CO2, it extinguished the reaction. That's because combustion reactions cannot take place if there's not oxygen present. So you will have one of your reactants, which are the things on the left side of the arrow, will have to be oxygen. But not every reaction that has oxygen as a reactant is a combustion reaction. You need to look for two other things. One, does it produce heat and light? Remember, we said combustion reactions release a lot of energy, and they release that energy as heat and as light. And then finally, combustion reactions very frequently have carbon dioxide and water as their products. So if you have undergone a combustion reaction, oftentimes you will see these as your products. Here's an example for you. A simple hydrocarbon, C4H10, reacts in the presence of oxygen, and it is burnt, and it produces carbon dioxide and water. All right, this is the end of our notes. You should be able to go and open your homework, which is the 9.2 check for understanding.